So kids, let's start today in 3.7. Our title of 3.7 is Transforming Polynomial Functions. Okay. You guys remember or recall last chapter we talked about quadratics, either moving left or right, up and down, vertical stretch, vertical shrink, horizontal stretch, horizontal shrink. Remember doing that stuff? Remember doing that? Yeah?
Yeah.
Okay. All right, so guys, today we're going to kind of look at the same things as they relate to polynomial functions. And I got to be honest with you, a lot of the rules that we've looked at in the past are very similar, if not the same, for transforming polynomial functions. Volunteer for my question here today. What are we trying to answer? Who wants it?
How can you transform the graph of a polynomial function?
Okay, how do we transform the graph of a polynomial function? So our goals today, describe transformations of a polynomial function, and then we want to look at writing transformations of a polynomial function. Okay, guys, you already know what a polynomial function is. All right, it's a function where you have integers for exponents, and takes on this form right here, a of n to the xn all the way down to a of 0. Okay, an example of a polynomial function, we've been looking at them all chapter, might be f of x equals 2x squared plus 6x minus 5. Okay, we've been looking at polynomial functions all chapter here. All right, that's not going to be anything that's too difficult. Okay. Then transformation. Transformation is simply some kind of a move. It's a move. Of a graph of a polynomial. It's a move of a graph of a polynomial. So, move of a graph of a polynomial. So it's like some kind of a shift, up or down, left or right. Might be a vertical stretch, a horizontal stretch. Might be a vertical shrink, horizontal shrink. It's just some kind of a movement. All right, we've talked a lot about this. Now, core concept. You guys have seen this before. Let's just kind of review or talk about what's here again. In this right here, this talks about all of your movements, and I think honestly, you're going to remember most of them, but this is pretty important, so you might want to highlight this or refer back to this. Let's look at some transformations. First of all, how many transformations have I listed up here? 5 of them, okay? First one's a horizontal translation, vertical translation, reflection, horizontal stretch or shrink, vertical stretch or shrink, okay? Up here they give you the notations, and I have to be very honest with you. The notations right here, the notations, this is really important. This here, the notations, gosh, if you understand what the notation looks like, you're basically just plugging stuff in for x as it shows up here notation-wise, okay? Horizontal translations, when you have f of x minus what, kids? Okay, right up here is an example. If I have x minus 5 to the 4th power, it takes that function, that minus 5 moves this what direction, kids, according to our chart? And you should remember this. Right, and then a plus sign inside of parentheses is going to move what direction? Left, okay? Vertical translations, f of x plus a k value. So we're adding or subtracting not inside of parentheses, but outside of parentheses. That's either going to, if I have a plus value right here, this is going to do what, kids? Up 1 unit. If you have a minus value, down 4 units. Okay, is this kind of coming back to you a little bit? All right. The reflections here, a couple types of reflections. If you have f of negative x, if the negative x occurs inside of parentheses, basically saying put negative x in everywhere there's an x. So flip over the what? Okay, so like right here. Negative x all to the 4th power is equal to x to the 4th power flipped over the y-axis. Okay. If you have a negative out in front of the whole function, then that's negative x to the fourth over the x-axis. Okay. Horizontal stretch or shrink happens when you multiply x by some value inside or outside of parentheses, kids. Right, this is a tricky one. If a is bigger than 1, it's actually a what here, kids?
Shrink.
Horizontal shrink. If a is less than 1 right here, like the 1/2, it's actually a horizontal.
Stretch.
And then how is the 2 related to 1/2 or vice versa? The 1/2 related to 2? What are they of each other?
Reciprocal.
Reciprocals of each other, okay? And then vertical stretch or vertical shrink, you're going to have some constant a out here times the whole function. So for instance, if x to the fourth again was the function, g of x would equal 8x to the fourth would be a vertical stretch by a factor of 8. If I had g of x equal 1/4 x to the fourth, that would be a vertical shrink. Okay, I think this chart's very important. Make sure you refer to this. All right, let's jump into what we need to get through today. Example 1. Ready to talk to me on this here? Annika, will you read number 1 for me, please?
Describe the transformation of f of x equals x to the third power represented by g of x equals, in parentheses, x minus 3 to the third power minus 1, then graph each function.
I'm not too concerned about the graphing part. We're going to look at the graphing part in decimals. But again, the original function is x to the what, kids? X to the third. So, I'm going to put that up here. X to the third power. And, you know, here's a graph you would get. There it is, x to the third, right there. Okay. All right. So you said, how do you make x to the third become g of x? X minus 3 to the third minus 1. Well, here's my description. Okay, does anybody know the movements right here? What's one movement? How many units, Sterling? Going to move right 3. How do you know right 3 there, Sterling?
Because the minus 3 is in parentheses.
Yep, the minus 3 is in parentheses right here. That's simply going to indicate you're moving that original function right 3 units. Then how about the minus 1 hanging out at the end, kids? How about the minus x, or I'm sorry, the minus 1 at the end? What's that going to do then? What movement's that going to take on?
Down 1.
Down 1, yep. The effect that these parameters have on the parent function x to the third is simply going to move it right 3 and down 1, okay? And I can check. If I go back here, I'm going to type in the second function, which is x minus 3 to the third. Whoops, didn't want to do that. Gosh dang it. Did that move right 3 units, kids? We'll take a look. Well, that point moved right 1, 2, 3. Did that move right 3 units, kids? That looks about right, doesn't it? Okay. Then we have a minus 1 here, so I should take this and shift it down 1. Okay. Has this point right here gone right 3 and down 1 to get here? At that value right about there? I'd say it has. Okay. Anything different than what we really looked at for transformations in the past? Give me some sort of sign that you're alive right now. Any difference really? No, not really at all. Okay. All right, so the graphing part, I think you can confirm stuff in decimals here. So here's what I want you guys to do. I want you guys to try example 2 on your own. Write down what you think that the description should be. Okay, if you're not sure, look at the chart on the front side of your notes. That should help you. guys, letter A says f of x is equal to the function x to the fourth. All of a sudden, x to the fourth became 3 times x to the fourth. Okay? You multiplied that whole function by 3. Anybody have a thought on how x to the fourth is going to transform to turn into 3x to the fourth? Yeah, it'd be a vertical stretch of 3. If I go back and say, oh, I took the original function right here, f of x, and times it by a value out front, well, a is bigger than 1, so it would be a vertical stretch. Did anybody call it a horizontal shrink? I would accept either vertical stretch or horizontal shrink. The thing you need to understand, a vertical stretch is the same exact thing as a horizontal shrink. So I'm going to write this down. Vertical stretch by a factor of 3. Put a 3 right here by that. Or it could be a horizontal shrink by 1/3. That would work. Okay? All right. Well, I'm going to guess most of you put vertical stretch for that. Guys, this one right here, how do you take x to the 5th and turn it into 0.5x? Now this is in parentheses, kids. 0.5x to the 5th. What's the 0.5x in parentheses going to do? 0.5 times x in parentheses.
Horizontal stretch.
It's going to be a horizontal stretch. What's the reciprocal of 1/2? What's the reciprocal of 1/2? It'll be a horizontal stretch by a scale factor of 2. And then Sterling, what's the other move on that?
Up to.
And also up 2 units. There it is. Okay. Again, you have to take the original function and say what parameters are being applied here again. And we've looked at this. And you should, like I said, you should know this. And again, this should not take long to go through today. I think you guys are going to have great success with this. Okay. Now, the part I'm a little concerned about right here, and maybe before I get started on it, anybody have questions so far? Are we pretty comfortable with movements right now? Okay, and we should be. All right, we should be. Okay, the example I am kind of concerned about right here is 3, and I think that if there's anything that's new in here, maybe it's right here. All right. Example 3 says writing transform polynomial functions. Okay. Instead of saying here's the function, describe the movement, we're going to do the exact opposite. They're going to say here's the movement, write the what? Here's the movement, what do they want you to write? They want you to write the... They want you to write the function. So suppose f of x is x to the 4th minus what? Suppose f of x is x to the 4th minus 1. Okay, it says write a rule for g and then graph each function. Not too concerned about the graphing. You can do that in Desmos to confirm this stuff. But it says describe the graph of g as a transformation of the graph of f. Ooh. All right. First one says your new function g of x becomes what here, kids? Negative what?
F of x.
Here's the deal. Okay, g of x. Whoops, didn't want to do that. Here's what I want to do. G of x would become the following. This is like saying negative 1 times all of f of x. Okay, now f of x is described right up here. What this is really saying is take your entire function, f of x times what value? Times negative 1. So to transform this right here, g of x would become the following. Help me with this, kids. In the first part up here, f of x was written as x to the 4th to begin with. But we want to times that x to the 4th times what, kids? So what's negative 1 times that x to the 4th going to get you? Well, wouldn't that just become negative x to the 4th, kids? What this sign out in front of f of x is saying switch every single sign in what? f of x. So you guys finish it. I started it out. The new function g of x, if it was negative f of x, or the opposite of f of x, would become negative x to the fourth. What's next? Plus x to the... Finish it. Plus 1. Yep. Okay. Basically saying negate everything. That's what that really said there. There's the new function. By the way, kids, putting a negative out in front of the function. Look at the front side of your notes again. Putting a negative out in front of the function has what effect? Flipping it over which axis? Take a look at the front of your notes.
The x-axis.
Yep, I flip it over the x-axis. Let's just double check this, okay? The original function was x to the fourth minus x to the third. Was it minus 1 or plus 1 to begin with, kids? Minus 1. There's the original one. This should get flipped over the x-axis. Let's see if that happens with what we came up with. What did we come up with?
Negative x to the fourth
Negative x to the fourth
plus x to the
plus x to the third.
plus 1.
Does it look like everything just got flipped over the x-axis? What was in green above the x-axis is now in purple below the x-axis, and vice versa here. Does that look like it's been reflected over the x-axis, kids? Okay. That's Under Armour's new symbol right there. You like it? Oh, you guys are tired, it looks like. Or sounds like. Are you guys, pinch yourself real quick. Everybody pinch yourself. Are you awake right now? All right. Well, let's roll. You guys help me with the next one. What's 0.3 going to have out here? 0.3 times the front of the function. Again, if I look at the notes, and these notes right here, it's like taking a times this function right here, f of
Students
x.
attending the JD Titan Challenge, please report to the front of the building at this time. Students attending the JD Titan Challenge, please report to the front of the building.
So some number times f of x is going to be a vertical stretch or vertical what? Hey, talk to me about this a value, kids. Is this a value more than 1 or less than 1 in this situation? It's less than 1. You thinking shrink or stretch, kids? Okay, so we have to write the function for this. Kids, here's the deal. G of x becomes 0.3 times all of f of x. Again, 0.3 times everything up here. So g of x is going to be, anybody want to take a shot at what that function is going to look like? Let's say I take 0.3 times all of f of x. So it's 0.3 times every term in f of x. Anybody want to take a shot at what this function is going to look like? 0.3x to the fourth. Good. I'm listening, Lex.
Minus 0.3x to the third. Minus 0.3.
You got it. It's pretty simple. Okay? I think the hard part for you guys right now is looking at the stuff that we've been doing has been so difficult. All of a sudden, today's stuff is very what? Simple. And that's the way we like it. Okay? All right, kids. Anybody need more time there? We're going to get through notes in a day. Can you believe that? Writing a transform polynomial function. Again, I maintain, I think that this stuff is kind of, tricky right here. This is the part, if any part, I would be concerned about, but I think we're going to handle it very well. Okay, it says let the graph of G be a vertical shrink by a factor of what, kids? By a factor of 1/2. So the first thing we're going to do is vertical shrink by a factor of 1/2, followed by what? 4 units. Okay, so the first thing that's listed up there is a vertical, what? Shrink by 1/2. Tell me what I have to do to f to shrink it by half right away. What do you have to do?
Times the entire equation by half.
Okay, so Sterling is saying to shrink it by half first. First step, shrink. by 1/2, you have to multiply the entire equation by 1/2. So let's do that first, kids. X to the 5th minus 2x squared is my f of x. Let's multiply everything by 1/2. So what am I going to get here, Sterling?
Half x to the 5th power minus x to the 2nd power.
Okay, that's the first one right there. Multiply everything by 1/2. We've already shrunk it by a scale factor vertically 1/2. Now the second part is to do what, kids? Second part is
4 down.
4 down. We have to move down 4. Okay, well, how are you going to move something down 4, kids? That's the second step. Move something down 4. What's the parameter you're going to attach to this now?
-4.
Subtract 4. Okay, just put a -4 at the end of this thing. So my new function is going to become 1/2 x squared after we've shrunk it vertically. And then what am I going to put at the end of this? Well, -4. So my new function, g of x, would be 1/2 x to the 5th minus x squared. That's the vertical shrink by 1/2. And now I want to shift that whole shrink down 4. There she be. I ever know people that throw their hands up in the air like this a lot. Anybody? You know anybody that does that a lot? Just throws their hands up? Oh, me. I could be a good football referee. Right? Annika, read 5 for me, would you? Let's get this done.
The function v in parentheses x equals x to the 3rd represents the volume in cubic feet of a cube with side length x. The function w in parentheses x equals v in parentheses 1/12x represents the volume in cubic feet. When x is measured in inches, write a rule for w, find the interpolate w in parentheses 96.
Okay, if somebody would read this right away, they'd think, wow, that's pretty kind of confusing right here. So we've got to come up with a function. First of all, it says volume x is equal to x cubed represents volume in cubic what here, kids? Feet. But they say the volume becomes 1/12 of x represented in cubic feet when x is measured in what, kids? Guys, how many inches are in a foot? 12. So we're basically saying the number of inches is 1 inch is 1/12 of a foot. That's what this is saying right here. So it says write a rule for w and interpret w of 96. Well, kids, v of x was equal to what here, kids? Okay, what they're saying is then w of x is equal to v times, in parentheses, 1/12x. So what this really becomes, w of x really becomes, instead of having x to the 3rd right here, what are we going to throw in for x right there, kids? 1/12x all to the 3rd power. So let's come up with a rule for this, okay? They're saying, hey, I want to know the volume in cubic feet if I measure stuff in inches. That's what they're saying. They're not saying we're going to measure stuff in feet. They're saying I want to measure stuff in inches. And in order to make inches work to kick out cubic feet, this is what we need to know. This w of x would become equal to, all right, help me kids, I need this. What's 1 to the 3rd power if I bring that into this? 1 times 1 times 1. Don't think too hard. 1, okay? And then I know the x to the 3rd is just going to be x to the 3rd out here. So I guess the question becomes is, what's this 12 to the 3rd power down here? Somebody run 12 to the 3rd for me. 12 times 12 times 12. Okay, so this is the function we end up with, kids, 1,728. Okay? So this is the function to represent stuff if you measured in feet. But let's say I have some kind of a rectangular prism, or cube in this case, where I measured x in inches. Well, this is what find and interpret w of 96 means. Okay? They're saying, hey, I measured one edge of a cube to be 96 inches long. Okay. Basically, they want you to evaluate W of 96. So this becomes 1 over 1728 times 96 to the third. All right. Maddie, can I count on your calculator again? Okay, I want you to take 96 to the third power and then divide by 1,728. 512. Okay, so this is 512 cubic feet. What this means is this: when a side of a cube is 96 inches, its volume is how many cubic feet? What do we end up with again, Maddie? Okay, I want you guys to think about this. I have a cube that's 96 inches on a side. Maddie, can I bug you again? Maddie, take ooh, I'm a little concerned about that. Maddie, run that again one more time. Go 96 times 96. No, never mind. I'm right. Listen to this. Take 96 and divide it by 12. You got 8, okay? Here's the deal. If I had a cube that was 96 inches long, that's the same as 8 feet long, okay? How do you find the volume of a cube, kids? How do you find the volume of a cube? What's the volume of a cube's formula? Come on, guys, this is easy. Length times width times height. So 96 inches, for that formula gets us 512 cubic feet. Maddie, go 8 times 8 times 8 if each 96 inch side is the same as 8 feet. Same thing, right? Okay, so this would be the formula saying, oh, if I know the number of inches, I take the number of inches, cube it, and then divide it by 1728 to get the volume in cubic feet. Okay? All right, kids. I'm going to give you the rest of the time to work on some things. I don't know where you're at right now.